Okay, hello, this is Dr. James, and today we're going to do a speed test of the Teensyduino 4.0, overclocking it. We'll see, usually I don't like to push the limits of something where you can really break it, but I have an extra one, and maybe you just need a little bit more speed, and I don't know, let's try that out and see what happens, because it should be cool to know if, like, so let's say we just need 10% more speed. Can we do it? I guess you're supposed to provide cooling if you overclock it too much, but supposedly you can overclock it a little bit without burning the thing out. And so let's give it a test. What I'm going to do is I'm going to do the same speed test that I did before, where I just write a bunch of high and low to output pin. I think it's pin 13 maybe, this corner pin up here. And we'll test that out and see how it works. Okay, we'll start out at 600 megahertz, and then we'll work our way up. Should be interesting. Okay, so we have our Teensyduino plugged into our computer up here. Okay, and here's our sketch. And I showed this one in one of my previous videos. I think it was called Speed Test at Teensyduino 4.0. And I have some unnecessary REM statements there, but let's, so we're setting the LED light to 13, and we're setting the pin output to LED 13, or pin 13, and then we're going to do a loop where we just write high, low, high, low, high, low, very, very quick, and this is the fastest way you can put out a signal. Of course, there's going to be a little disruption in the signal when it loops around again, because it takes a while for the loop to go back to the beginning. But we can see how fast it can execute these operations by just measuring them on an oscilloscope. And let's go up here. We're going to go to Tools, and see Teensyduino 4.0. It's set at 600 megahertz, and there's different clock speeds. You can actually slow it down too. Maybe we'll try slowing it down first to see what effect that has, and then we'll do some overclocking. Okay, make sure it's plugged in. Okay, and let's just we're in the sketch. Okay, so we'll click upload, and it's uploading the sketch, and I think we should be all set to go. Let's get our scope fired up, and we'll test the frequency on this. Okay, should be interesting. Okay, so I got my scope probe in here, and I just have the ground flying because the signal's so fast you can capacitively couple the other ground to that. And so I can still measure the frequency just by sticking a single probe in the pin out. And it looks like we are getting a frequency of about 11.2 megahertz. Very interesting, huh? Of course, that jitters because every once in a while it has to reset the clock cycle. It might trigger in a different point, so you may not get. Let's zoom out and see what's going on here. Actually, so oops, zooming the wrong way. The scope is getting old. Sometimes the twirly knob. So see, there's a reset right there, so that's where it loops around again. So it seems to be triggering on that particular point. And then it will have a whole burst of signal. Come on. Sometimes it's going the wrong way. This twiddly knob is getting old. Okay, anyway. So that's what we're dealing with there. So let's try, before we go to faster clock cycles, which are dangerous, we'll try slowing it down and see if that changes the speed at which this thing writes, which it should. Okay, should be interesting to find out. Okay, so let's go into our program here. Let's see, Tools. Okay, we'll change it to 528 megahertz. How about that? And then we'll try writing it. Okay, so the exact same sketch, but 528. This thing loaded up. I don't know, I can't tell much of a difference. Oh, did we load it? I think we might have just compiled it. Let's load it. Make sure it's loaded in. Okay, it says done uploading. Oh, look at that. We have a different frequency now. Let's get our cursors on that. So I'll put the cursor about in the same spot that that one is, the same cycle. And it looks like we are down to about 9.47 megahertz now. Okay. So changing the clock cycle does make a difference. Very cool. Let's see, is this thing in focus? Okay, so let's try Teensyduino. Okay, so we're at 528 megahertz. Let's go down to 400 megahertz and try uploading that. Okay. Uploaded. Very cool. We still got our scope probe in there. I'm going to have to change the scale on the scope. Okay. So, we'll put this at the same phase as the other one. Looks like it's about there. And we're at 8.33 megahertz. Very cool, huh? So we're changing the frequency output by changing the clock speed. So some people might want to run it slower because it would use less energy. Let's feel this thing. It's a little bit warm, even though it's running slow. Okay. Let's go all the way down in frequency, then we'll maybe go back up to 600 megahertz and then above. Here we go, 24 megahertz. And let's upload that guy. Okay, so it's compiling it. Upload, done. Ooh, it's very slow now. The signal's actually bigger. It's not really bigger because probably the scope is, it's just capacitively coupling before, so. Oh, come on, really? Okay, so there we go. And in order to measure the frequency, you just have to have it in the same phase point. So I'll put on this the third ripple there, the third ripple there. And it looks like we are down to 439 kilohertz now. It's right there. So, 439 kilohertz. Okay. Now I'm going to bring it back up to 600 megahertz clock speed. And then we'll start going up from there. And I'll have to be careful because I really don't want to burn out my device. So, tools. I'm just going to do the 600 megahertz to get the scope set up to approximately where it needs to be. Because I don't want to be fiddling around with the scope a lot when it's, running at super fast speeds. Okay. Their signal's lower again. Okay, so it's about 11.2 megahertz again. Alright. Get the cursor set there. And let's try overclocking it a little bit. And I will maybe... Oh, you know what I should do? I should get my thermal gauge and take a reading of this while it's running so I can see how hot it is. That would be cool, wouldn't it? Okay. Okay, so right now we're running this guy at 600 megahertz, right? 600 megahertz up here. Tools. See, it's on 600 megahertz. And here's our IR thermometer. And we will point it at that guy, take a measurement. Okay, so it's telling me 27 degrees. Okay. Okay, so this is measuring about 27 degrees on our chip, and it's running with an output of about 11 megahertz. It's able to switch that fast. Okay. Very cool, huh? 27 megahertz. Okay, so let's now we'll go to Tools, Clock Speed. We'll go all the way down here to 720 megahertz overclocked. Okay. Oops, and before we look over there, let's upload our sketch. Uploading it, compiling, uploading, uploading done. Okay. And let's measure our frequency here. Okay, we'll get the cursors in place. And that is about 12 megahertz. Well, actually, that's not the same phase. That's about the same phase right there. It's about 13 megahertz. 13 megahertz. Okay. It's screaming fast now. We're overclocking our device. And let's take a look at... Oh, my tape broke away. Let me fix this. Okay, let's get our IR thermometer out, and we'll take another measurement here. Okay. Well, it doesn't seem to think it's getting any hotter. It's only still about 27, right? 28 maybe. Okay. I can't tell too much of a difference. And I'm measuring on the chip there, seeing what the temperature is. 26. Okay. Okay, well, we got a little bit of extra speed out of that, and it's not burning up. Let's try overclocking it some more. 800 megahertz overclock. Okay. See, so we got it set to 816 megahertz. And let's download our sketch. It's downloading it. And we will see if the frequency changes. Look at that. Oh, this is so cool. I'm going to move the cursors over to these peaks over here because it looks like that peak is a transient or something. Try to get a measurement here. Okay. And it's telling me about 15.2 megahertz. 15.2 megahertz output from our Teensyduino device here. Shit. Let me grab that. Okay, let's see if the temperature is going up. It's still saying 27 degrees. Huh. Maybe 28 degrees. $29 degrees. Okay, it might be going up a little bit now. 28, 30. $29. 36. Oh. I'm measuring it on different spots. It's getting a little bit hotter. Let's see. Measure it with my finger. Okay, so let me move the trace over a little bit, and okay, let's go up to a little bit higher speed, shall we? $816, 912. All right, 912 overclocked. Okay. And it says we need cooling for that one. Let's try uploading this one. And I will see if we see a change on the scope. And we'll try to, oh, look at that. Okay. Okay, so that's about in the same spot. So it looks like our output is about 16.9 megahertz. Okay. Right there, 16.9. Sometimes this thing doesn't focus right. Okay. Now let's take a look at our temperature, see if we're getting too hot here now. Oh, shit. Okay. And I think I can feel it getting warm on my lap. Let's take a look at this. 30. 35. 29, 31. $35, $36, $38. So it seems to be getting a little bit hotter now. And of course, oh, come on. Do the finger test. Okay, so it's getting a little bit warmer than what I like. I might unplug it for a second and let it cool down. Okay. And then we'll try to change it up to the next speed, and we'll see how fast we can get it. Let's run it for a short burst, maybe. Okay, so I just uploaded to 960 clock speed, and let's see. So it's, according to my estimate, about 18 megahertz. Now, let's check the tools again. 960 megahertz right there. And let's check our temperature. Okay, so we have our Arduino here. And there we go. Of course, I unplugged it a second ago. So maybe, let's make sure that we let's feel it. 960 megahertz. Okay, so it's cool again because I unplugged it, but it's beginning to warm up, I believe. Okay. Okay, it's only at 28 right now, and it doesn't feel super hot. So I might just unplug this again and let it cool down, and it's not too bad right now. We'll go up to the max speed here, 1.008 gigahertz, or it's 1 gigahertz basically. All right, 1 gigahertz clock speed. Look at that. 1 gigahertz clock speed. And I'll wait a second, plug it back in, and then upload it, and we will see what happens with our device. Okay? Very cool, huh? Okay, we got our thing uploading at 1 gigahertz clock speed. And let's take a look here. Oh, look at our signal. Oh, it hasn't changed, has it? It says uploading done. Okay, I guess maybe it's not that much of an increase. It's hard for me to tell. Looks like 18.9 megahertz, almost 19 megahertz output. And let's take a look with a thermometer, see how our guy is doing. So again, I let it cool down for a little while. So maybe it takes a little while for this thing to heat up. We're at 29 now. Oh, well, it's feeling kind of hot actually. Oh, okay, yeah, it's getting hotter. It's like 30, 36 in some spots. Okay, yeah. I'm not going to leave it run for too long like this. I think I'll just unplug it. Okay. So there we go. Teensyduino overclocked. Almost 19 megahertz output from switching the pin as fast as we can switch it. And it is getting warm. Probably if you leave it for going for too long, I mean that was just a minute or so, it will probably not be good for the device. But it looks like it survived that. So we can overclock it for short periods of time without cooling, it looks like. Okay, anyway. Okay, just to make sure, I reloaded the clock speed back to 600 megahertz to make sure I didn't damage it. And it looks like it's operating as usual. I didn't move the cursors, but that's probably about 11 megahertz or whatever it was before. And so it looks like it is still working, so we didn't destroy our device by overclocking it. Very cool, huh? Anyway. Very cool overclocking experiment, huh? Okay, anyway. This is Dr. Janes, and thanks for watching.